use our knowledge of limits to talk about limits to infinity, or limits that approach infinity. So before we do that, though, we need some vocabulary and some illustrations. First one is asymptote. Asymptote. I'm also going to be drawing a picture here, so make sure that you're drawing it in addition to writing down the definitions. An asymptote is a line. Oops, not line. Line. A line that approaches a given curve or graph. You'll hear me use those two words interchangeably. Am I off screen? Okay, thanks. But does not meet it at any specific y value. I thought you said you went to go get water.
Oh yeah, but I want to so I'm gonna wait.
Xavier, you're just gonna go get water, right? Go ahead. So I'm not sure if you talked about this last year in your math class, but an asymptote is basically an understood line or an invisible line that your graph gets closer and closer and closer to, but never touches or crosses. It does not touch or cross. So let me draw a picture so you can see it visually. So here's your coordinate plane, and I'm just drawing a random graph. So for those of you who are wondering where I'm getting this from, I'm just making it up, okay? Excuse me. Thanks. Let's do. Excuse me. Thanks. Okay. So here's a random graph I created. This graph has asymptotes. These are lines that your graph gets closer and closer and closer to, but never touches. So if we look at this, we have one asymptote here. So this is an invisible line or an understood line that your graph gets closer and closer to, never touches or crosses. There is another one on this side. That your graph gets closer and closer to, but does not touch. These have specific names. They have specific names. So when we're talking about getting closer and closer to, but never touches, we're going to be talking about limits. Our first definition for an asymptote, our first specific asymptote is called the horizontal asymptote. Ladies. Horizontal asymptote is a horizontal line horizontal means that it's going left and right. That the graph of a function approaches, am I off screen?
Yeah.
Okay. Is that better? Approaches as x approaches positive infinity or x approaches negative infinity. As x approaches positive infinity or x approaches negative infinity. What that means is that the values of x are, excuse me, thanks, are increasing or decreasing to infinity or negative infinity. That means they're getting really, really big. I'm off screen. Really, really big or really, really small. Really, really big or really, really small. So this right here, this purple reddish line is your horizontal asymptote because it's a line left and right and your graph is getting closer and closer and closer to it but doesn't touch it. Does anybody need me to zoom in on a graph so you can see? That's as best as I can get. What'd you say? Right here? Yeah. Infinity or negative infinity? Thank you, Leland. Yadira is, and then Andrea. To note, so make sure you star this, highlight it, circle it, whatever. The limit for this will 99% always approach a specific value. %of the time, it will approach a specific value. Gentlemen.
Sorry.
That means when I ask you for the limit, where x approaches negative infinity or positive infinity, you're going to give me a number. Okay? Alright, we're almost done with notes and then we'll get to the example. Vertical asymptote. Vertical asymptote. A vertical line, am I off screen? Okay, thanks. It is a line that goes up and down. That guides the curve. Of the function to positive infinity or negative infinity, but in the y value. Yep. But does not cross it or hit it. So for this, we have a specific x value. But the y's now are increasing. I'm going to abbreviate because I'm running out of space. Increasing or decreasing to positive infinity or negative infinity. These limits will approach which one? Here? Increasing, decreasing. Will approach a negative infinity or positive infinity. Give me 1 second. Does everybody have that down so I can show you on the graph? Okay. No? I heard a no. I'm waiting. Good?
Yeah.
Okay. Okay, so on the graph, this turquoise line is the vertical asymptote. So this is the understood. I'm abbreviating, just so you know. This? Yeah, I said write down the graph. Do you want me to zoom in? So this one was the horizontal and this one is the vertical asymptote. Okay? We've got some notation and then we'll do the examples. Yoselin, you ready? Okay. Can I go? All right. Okay. Limits and infinity notation. Gentlemen. Okay, first one, Andrea, is horizontal limit. They already ended your pass. You dear. They already ended your pass.
Huh?
They ended your pass already. So the horizontal limit, remember, is going left and right. We have two notations for it. We have the limit as x approaches negative infinity of some, oops, forgot, f of x. And you're always going to get a value. You will sorry, I'm not going to say always. 99% of the time, you will receive a value, a number, okay? You'll always, 99% of the time, you'll get a value, okay? This is when your x values, or the arrow on the graph, decrease. And you'll see what I mean when I do an example. The other notation for horizontal asymptote is the infinity one, the positive infinity. So if this is going to decrease, the x values or the arrows decreasing, what are the x values going to do here? Increase. Oops. Am I off screen? Alright. I need you to split up or I'm going to remove you. Please. I'm trying to be nice as I can, but split up or you'll be removed. When we go to group work, you can go back, okay? All right. The next one we have is the horizontal, nope, that's horizontal, vertical. This one, though, we have 3 different notations. And the reason we have 3 different notations is because we can have a left, a right, and one that's put together. For the, for the horizontal asymptote, we cannot. Vertical, we can have a left, a right, and a together. For horizontal, we cannot. So, the first one is from the left. Am I going too fast? Sure? Okay. As x approaches a from the left of f of x, we can get positive infinity or negative infinity. One of those 2 answers, but not both. It's one or both. I'm sorry, one or the other, not both. So if we have the left, we can do the right. Again, we can get positive infinity or negative infinity, but not both. Not both. You can have one or the other, but not both. How is it that you're split up and we're still distracted? And then we have the together limit. For this, depending on what happens here, you can have positive infinity, negative infinity, or, what do we think? Does not exist. I heard somebody whisper it. Because remember, if these 2 are different, then the limit won't exist. So we are still using the same concepts that we used the last couple of weeks, but now we're involving infinity. Once you have copied this down, take out the sheet that I gave you. You do? You need just. You need to. You good? Good. You good? Let me know when you're ready. Gentlemen, you ready over there? Lalo's group. Rodrigo, let me know when you're ready. You guys good? Edward, let me know when you're ready. Ready? They're not saying anything, so I'm just gonna go. Okay. All right. So on here, you have level 1 and level 2. That's what your exit ticket's going to be on tomorrow. Tomorrow, you're going to have practice and then an exit ticket like before. Practice and then exit ticket. Seniors, it's very, I don't know what word to use, but it's very, I don't know, weird of the number of students who aren't getting level 1. All you're doing is you're taking a sentence and writing it in math. That's all you're doing, okay? So if you really don't understand level 1, and I'm not trying to throw shade, but I kind of am, Brian, wake up. Pay attention right now, okay? I'm going to try to circle and use colors. So what you're doing is you're taking a math sentence and you're writing it in notation. So the limit. What is the symbol for limit? L-I-M. Very good. X approaches. What symbol is approaches? No, not a negative. It's an arrow. Negative infinity. That goes there. Am I going too slow? Too fast? Too slow? I know. I just want to make sure people understand. F of x. I guess I should use a different color. Whatever. Equals 4. All right, boys. You need a break. Brian, wake up. Brian, wake up. I have 2 removals and 228, please. Thanks. Bye. I tried, gentlemen. Okay. Any questions on that? There's no reason you should not be getting a level 1. There's going to be 2 questions like this on your exit ticket and on your quiz. We already know limit is LIM. X approaches is X with an arrow. We know what 10 is, or should know what 10 is. F of x. Okay. Now, at this point, students will see approaches and write another arrow. You good? Edward and Rodrigo. I'll send an email in a second. You two are next. But we can't say something is equal to infinity because nothing can be equal to infinity. Okay? So that's why we say mathematically approaches, but in limit notation, we can still write equal. Okay? We can still write equal for that, even though we say approaches. Okay? Because we can't say something is equal to infinity. Okay? No? You don't get it? No, for real. Okay. And then negative infinity. Negative infinity. Questions? Good? For level 1? Okay, let's look at level 2. Alright, I'm going to try to get both things in. Okay. So this is level 2. We've got the limits, and you have to write the limits. Okay? So we have 3 from the left. Right now, I'm gonna give you the asymptotes where the line is. You know how I had you draw a line at those values? Asymptotes will be given with a, excuse me. This is your last warning. Do you need to go step outside for a second? Either of you? Okay. Asymptotes will be given by a dotted line. I am going to draw that anyway so you can see what it is, okay? So I'm going to go for 3. Here's 3, and I'm going to go from the left. So you're using the same process as you did when we were doing the limits before. Gio, go get water. What value is this approaching? Is it approaching a value? Like, is it approaching a number? No. And this is what you need to look at. If your arrow or if your y values are decreasing, this is going down, this is decreasing, it's decreasing to negative infinity. So that's your limit, negative infinity. Do we see that? The arrow is pointing down, it's going to negative infinity. Arrow is pointing down, it's going to negative infinity. Now, when we look at 3 from the right, so I'm going to go to the right, where is this going? Positive infinity, because your arrow is pointing up. Somebody asked in the last class, do you have to put the positive sign, or can you just write infinity? Yes, that's fine. You can put the positive, or you can just write infinity. I don't care. I like to do it either way, so you'll see me do it either way. Do you need to stand up here, dear? Are you good? Okay. Questions? Are we sure? All right. Let's do now the limit as x approaches 3. Remember, for a limit to exist, both the left and right hand limits have to equal. Are these equal? So then, does not exist. Do you guys want me to say that again? Okay. For a limit to exist, so just for like the 3, without a left or right. You see that there's no left or right thing up here? These two values have to be equal. Negative infinity and positive infinity are not equal. They're not even approaching, like they're going in opposite directions. So there is no limit. Okay? That makes sense now, Andrea?
Yeah.
Okay. Questions? All right. Last 2. And this is where students get confused. And it's okay because this is the first time we're working really with infinity. Students will see this. They'll see x approaches negative infinity and think, oh, this is going to negative infinity, so it's negative infinity. No, no. We are looking, when we're looking at these that have infinities, we're looking to the left for negative infinity, and we're looking to the right for positive infinity. We're looking for the left and to the right. So if I look to the left for negative infinity, because this is negative infinity, am I off screen now, right? What is value do you think this is getting closer and closer to? What? 3, very good. This function will eventually approach 3. Do we see that? I see some confused faces. Do you need me to zoom in? Do you need me to explain it again? Yeah? Okay. So, these are my x values, right? We know this is the x-axis, right? The question was asking me to find the value as x approaches negative infinity. Negative infinity is to the left, correct? So you're looking to see where it's going to get closer and closer to, but never touch. And that value is 3. Okay? Do we see that now? Are we sure? Okay. Mel? All right, the last one. We're going to the right now on the graph. It's right here. This is approaching positive infinity. What y value will this approach? Well, huh? Yes. Me? Yes. So in the graph, it looks like it's gonna approach. Oh no, it does approach 2. Wait, this isn't 3. What is this? That's 2. Sorry. 2. Sorry, give me a second. Sorry, I haven't had time. Yeah, she's fine. Questions?
No.
Sorry about this one. Sorry, I was distracted. They distracted me. Huh? I'll give it to you. Yeah, it's 2. I'm sorry. That was my fault. It's getting closer and closer to 2, not 3. That's why some of you were confused, right? Yeah, it's getting closer to 2. I'm sorry. He was out there in my window distracting me.
Wait, number 4 is 2?
I'm sorry. Yeah, number 4 is 2.
Number 5 is 3?
Number 5 is 3. Questions? You sure? Okay. Flip over to the back. You have 1 problem, well, 2 problems to do with your group. I need to send this email.